As we continue looking at our transformations in section 2.6, we are going to actually, apply some transformations, see what happens to our graph. So let's say we have some, random function, y equals f of x. Maybe it's y equals square root of x, or maybe it's y equals x to the third, or whatever our function is, okay? One change that they can make is they could put plus a number at the end. So in other words, maybe it's y equals square root of x plus 2, okay? Well, what's going to happen is because of that plus 2 that's out separate from the x part, separate from square root of x, it's being added on separately from that, this graph is going to move 2 units up. So if you add some value, some c number to the end of whatever your function is, it's going to shift it up by c units. On the other hand, if you put minus some number, minus c, so maybe we have y equals x to the third minus 4, okay? This minus 4 on the end is going to cause our graph to move down c units. In this case, it moved down 4 units, okay? So if our plus or minus number is separate and away from the x's, it's going to cause a vertical shift. And by shift, I just mean it's going to pick the whole thing up and move it. So in other words, I had this square root of x plus 3. I wrote a little plus 3 here. What that would do is take this little curve and push every single point up 3 units. So the point that used to be at 0, 0 would now move up to 0, 3. The point that used to be at 1, 1 would move up to 1, 4, and so on. The shape would be exactly the same. It would just push the whole thing up. If we'd had a minus 1 at the end, I put a little minus 1 on this x squared, it would take this whole parabola and move it down 1 unit. That's what the minus 1 would do. So it would keep the exact same shape, it would just move it down by 1 unit. Okay? So if you add or subtract something separate from the x, totally out away from the x, it causes a vertical shift. Okay? The other way that you could add or subtract something is in parentheses with the x. So in other words, let's say that I had y equals x squared, but I changed it to x plus 1 squared. Do you see how this plus 1 is in parentheses with the x? That means something's going to happen sideways. It's not moving up and down. It's in parentheses with the x. So something's going to happen horizontally on the x-axis. Okay? Let's say that my original equation had been square root of x, and I put square root of x minus 2. Notice that minus 2 is under the radical symbol with the x. That means something is going to be happening horizontally. Okay? X-axis goes horizontal, so if you put a number in the parentheses with the x or under a radical with the x, something horizontal is going to happen. So adding or subtracting something to the x is going to be a horizontal shift. Okay? Now, here's the other weird thing. Horizontal stuff, x's, they always lie. X's are big liars, okay? So you would think, oh, plus 1, it's going to move sideways. It's going to go to the right. But x's lie. This will actually go to the left, okay? You see a minus in there. You go, oh, minus, it's going to go sideways. It's going to go left. It actually will go to the right. So anytime you put something in with the x's, it's going to go the opposite direction that you would kind of expect. It's going to go backwards. I'll show you why that is in a second. All right, so if we put a minus h in parentheses with the x, it's going to go sideways, and you would think a minus would go left, but it really goes to the right. Okay, so it will shift h units to the right here in this blank. If we have an x plus h in parentheses, then it's going to take our original f of x and shift it h units to the left. Okay, let's explore that idea a little bit more. Okay, here is an equation, g of x. Our parent function is just the square root function. All right, so if I go to my y equals here, and I type in square root of x, and I look at my table, I can see some values. Now notice it says error on the negative x values here? Because remember, you can't put a negative number into square root of x. You can't do that, right? Can't take a negative square root. So, watch what happens here. If I go to 0, my y value is 0, because square root of 0 is 0. Square root of 1 is 1. That's why 1's on my graph. 2, I don't really love taking square root of 2, but if I did, I'd get 1.4 something. Square root of 3 would give me 1.7 something. Square root of 4 would give me 2, and so on. Okay? Now, what would happen if I found square root of x plus 2? Notice this plus 2 is not in parentheses. It's not under the radical with the x. That means it is separate from the original function. It's going to be an up or down change. In fact, it's going to go up 2. So basically what's going to happen is I'm going to take all of these original y values and I'm going to add 2 to them. I'm going to shift the whole graph up 2. My original function went through 0, 0, 1, 1, 4, 2. There's the 2 and 1.4. You could estimate that. So there's our original function. Regular old y equals square root of x is right here. This plus 2 is going to make it move up 2. So if I go to my y equals here, notice I arrow out of the radical before I hit my plus 2. And now when I look at the table, I'm going to change colors so you can see it a little bit better. When x is 0, y is not 0 anymore. Y is 2 because it took that point that was at 0, 0 and moved it up 2 units. The point 1, 1 isn't there anymore. It's now 1, 3. Okay? Because it took the point from 1, 1 and moved it up 2. I can add 2 to all of these y values. And of course, 2 plus 2 is 4. The point that used to be at 4, 2 is now at 4, 4. Notice how it took that original function and moved it up 2. Okay? All right, so what I like to do is I kind of have my parent function, that Furious 5, memorized. I know square root of x goes through 0, 0, 1, 1, and 4, 2. I know that. So now that I see this plus 2, I know I can take my original y values and add 2 to all of them. So I'm going to take these y's. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. That's where those values came from. The point that used to be at 0, 0 is now at 0, 2. The point that used to be at 1, 1 is now at 1, 3. The point that used to be at 4, 2 is now at 4, 4. And I can come up with this table and sketch those points pretty quickly, even without a calculator. Okay? Now, let's look at this one right here, this f of x. It's still got a plus 2, but notice the plus 2 is under the radical. This plus 2 was separate from the radical. This plus 2 is in the radical. So it's not a vertical change, it's horizontal. That plus 2 is in the parentheses, or not in parentheses, but under the radical in this case with the x. So it's going to be a sideways shift of 2 units. Okay, it's going to go sideways. And remember, x's lie. You would think plus 2 would send it to the right, but it's actually going to send it left 2 units. Okay, let's verify that in our calculator. Square root of x plus 2. Notice I kept the plus 2 under the radical. I did not move it out separate. When I go to the table, now notice what happens. When x is 0, y is that 1.4 number. When x is 1, y is the 1.7 number. When x is 2, y is 2. Well, this is strange, isn't it? You can copy down these last couple numbers. What do I have to put in for x in order to get that 0 to come out? Oh, notice now I have to put negative 2 in for x to get a 0 to come out. Now think about why that is. I now have to put negative 2 for x because negative 2 plus 2 is 0, so that when I take the square root I get the 0. Okay, so notice I've now got to go to negative 2 to get that 0 to come out. If I'm at 0, my y value is 1.4. If I'm at 1, the y value is 1.7. If I'm at 2, the y value is 2. Notice how it took that same original parent function of square root of x, but it moved it to the left 2 units. Okay? Little trick I like to use. If I can make this table by hand without my calculator. I know that 0, 0, 1, 1, and 4, 2 are key points on the parent function. I know that this plus 2 is going to move my graph left 2. I know I can take all of my x's and subtract 2 to make it move left. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. The point that used to be at 0, 0 is now at negative 2, 0. The point that used to be at 1, 1 is now at negative 1, 1. The point that used to be at 4, 2 is now at 2, 2. Do you see how it took each of those key points and moved them over a little bit from where they were? Okay, let's try another one. Parent function. Well, parent function here would be just x squared. Okay, so key points on my y equals x squared. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and so on. I would point out they did not put any negative numbers in for x, but if they had put negative 1 for x, we would have got a 1 for y. If they had put negative 2 for x, we would have got a 4 for y. So I'm going to come over here and plot a few of those. 0, 0, 1, 1, 2, 4. Can't really go up to 12 or 9 or whatever. But I can go to negative 1, 1 and negative 2, 4. So there's our parent function. Okay, that's our y equals square root of x. So what's going to happen with this minus 2? What's going to happen to our graph? Well, that minus 2 is not in parentheses with the x. So it's not going to be something horizontal. It's going to be vertical. And this minus 2 is going to make it go down 2. Okay? So you could fill this in with your chart. You could say, hey, what happens when you do x squared minus 2? And you can copy those ordered pairs down. Okay? You can say, oh, the point that used to be at 0, 0 is now at 0, negative 2. The point that used to be at 1, 1 is now at 1, negative 1. You can copy those down. Or, if you've memorized your Furious 5, if I put negative 2 in for x squared, I get 4. If I put negative 1 for x squared, I get 1. And then I know this minus 2 is going to move things down 2. So moving things down changes the y's. So I'm going to minus 2 on all my y's. 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. So now I've got all those key points right there. The point that used to be at negative 2, 4 is now at negative 2, 2 after I do the subtracting. The point that used to be at negative 1, 1 is now at negative 1, negative 1. I'm taking this point and moving it down 2. The point that used to be at 0, 0 is now at 0, negative 2. It moved down 2. The point that used to be at 1, 1 is now at 1, negative 1. Took each of these key points and moved them down 2. Okay, you can verify that by graphing in your calculator. Okay, this one still has an x squared, but notice where's the minus 2 this time. It's in the parentheses with the x. That means it's sideways, and x's always lie. You would think minus left would send it or minus 2 would send it left, but it's really going to send it right 2. So it's going to take our original pink parabola here and move it right 2. So, in fact, I'm going to draw them on this other graph here. There were our original parent function points. Okay. since something is happening sideways, it's going right 2. Moving stuff sideways changes our x values. We know it's going to go right 2. So if I need to move it to the right 2, I need to add 2 to all of my x's. So I'm going to take these x's and add 2 to all of them. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 0. 1 plus 2 is 3. 2 plus 2 is 4. So the point that used to be at negative 2, 4 is now at 0, 4. The point that used to be at negative 1, 1 is now at 1, 1. The point that used to be at 0, 0 is now at 2, 0. We have a point at 3, 1 and at 4, 4. Notice how it has taken that original graph and moved it right 2. You could verify that in your calculator if you wanted to. You can type parentheses x minus 2 squared, and sure enough, it took that original parabola and it moved it right 2. You could verify by looking at points in your table that we have good points here. Okay? All right, let's put some of it together. What is going to happen to this function here? Well, what was the original? I've got an x and I've got a squared, so I know it was originally a parabola. And I know that parabolas go through the point negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. If you're not sure, you could experiment by just saying, okay, what if I squared all these numbers? Negative 2 squared is 4, negative 1 squared is 1, etc. Or you could use your calculator. Okay, these are the normal points I would expect with an x squared. But what is this plus 1 going to do? Well, that plus 1 is in parentheses, so something sideways is going to happen. And it's with the x's, and x's lie. So normally I would think plus 1 would move to the right, but it's going to move to the left by 1 unit. This is going to have a horizontal shift, moving sideways, left 1 unit. Okay? Okay, so what change am I going to make? I'm going to change all my x's. Whatever the old x's were, I need to move them left 1, which means I need to subtract 1 from all of my x's. So I'm going to take all these x values and I'm going to subtract 1. Okay, negative 2 minus 1 is negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. Okay. What about the minus 4? Well, the minus 4 is not in parentheses with the x, so it's not something sideways. It's going to be something vertical. And y's behave. Y's always do exactly what they're supposed to do. So this is going to move down 4. So I'm going to leave my x's alone. I've already made my change to the x's. But because of this minus 4, I got to move all the y values down by 4. I'm going to subtract 4. 4 minus 4 is 0. 1 minus 4 is negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 4 minus 4 is 0. So on my graph, the original point, remember the very middle of your table here is the original. The original graph used to have a point at negative 2, 4. But that point, so negative 2, 4 will be right here. But that point moved left 1 and down 4. So the point that used to be at negative 2, 4 is now located at negative 3, 0, right here. The point that used to be at negative 1, 1 is now located at this x of negative 2 and this y of negative 3. So negative 2, negative 3. The point that used to be at 0, 0 is now at negative 1, negative 4. The point that used to be at 1, 1 is now at 0, negative 3. And the point that used to be at 2, 4 is now at 1, 0. Notice what has happened. The original parabola would have had its vertex right there at 0, 0. See how that point went left 1 and down 4. Okay? As a check, you could go to y equals, type in this equation, x plus 1 squared minus 4, and look at your table. Notice -3, 0 is a point that's on my calculator. -3, 0 is a point on the table I made by hand. -2, -3 is a point on my calculator and a point on the table I got by hand. -1, -4 is on there. 0, -3, 1, 0. All those points are on there. I was able to draw this graph by knowing transformations and what would happen to my parent function. Okay, let's try another example. What is the parent function of this one? Well, I'll see these bars here. I bet the original parent function is absolute value of x. Do we know any key points on y equals absolute value of x? Well, I could use my furious 5. Okay. If I put in -2, what's the absolute value of -2? Well, +2. What's the absolute value of -1? 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. That would give me that V shape. Okay? But this function is not the regular absolute value function. What have they done to it? Well, they put a -2 in the absolute value bars with the x. Remember, the x is always sideways stuff. X is always lie. You would think it would go left tube, so it's really going to go right tube. Okay? Well, what am I going to do to my ordered pairs then? Well, sending something to the right moves it to the right. That's going to add value to my x's. X is lie. You would think you would -2, but we're really going to add 2. So -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Okay. What about the +3? Well, the +3 is not in the absolute value bars with the x, so it's not sideways. It's going to be something vertical. And the y's do exactly what they're told to do. So we're going to add 3 to all of them. This is going to make the graph go up 3. So I'm going to take all my y's, and I'm going to add 3. 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. So now I know original points, and I know the transformation points from this new function. The point that used to be at -2, 2 is now at this x and this y, 0, 5. The point that used to be at -1, 1 is now at 1, 4. 2, 3 is our next point. 3, 4. And 4, 5. There's our new graph. Notice that it's still absolute value. It's still the V shape. But it moved right 2 and up 3. This whole V went right 2 units and up 3 units. If you want to check in your calculator, math, arrow over to number, pick absolute value, and you can type in x minus 2 outside of the bars plus 3, and you can verify. You can get some points on your table, and you can plot them, and you can go, well, look at that. That's exactly what I got by hand. Okay? So one way we can transform graphs is by moving them left and right, or up and down. We call those vertical shifts for moving up and down, horizontal shifts for moving left and right. Okay? That's what this video was about. The next video, we'll look at another type of transformation that we can make.